Happy 2021 and welcome back to the second season of Looking at Lyme. We are thrilled to get started again. Today, buckle up your seatbelts because we are going on a science adventure with one of the most accomplished researchers in neuroinflammation. Now, I know you're not all scientists, so don't get overwhelmed. Just go to our show notes and you'll find the link to the presentation. Dr. Theoharis Theoharides is a professor of immunology at Tufts University in Boston, Massachusetts. He has spent a lifetime studying neural inflammation. It is one of the most debilitating symptoms of Lyme disease, or at least it was for me. Neurological complications can lead to numbness, pain, weakness, facial paralysis, fever, and headaches. Dr. Theoharides is discovering ways to ease that suffering, and we are delighted to have him with us here today. Hello, Dr. Theoharides.
Hello there. What a pleasure to be with you.
Thank you so much for joining us on our podcast. I feel so lucky. I saw you present at the ILADS conference in Boston in 2019, so I'm very excited to have you with us today.
Ooh, lots of things have happened since then.
Absolutely. That's true. Well, I'm wondering if for our listeners, we can just start with the very basics of what are mast cells and what role do they play in our bodies?
Well, it's fascinating. Mast cells exist in all tissues of the body, including, interestingly, the brain that does not get allergic reactions. And mast cells have existed for over 100 million years. So they exist in worms, fishes, lizards, etc. And those species do not get allergic reactions. Now, why have the mast cells been associated with allergic reactions is for two reasons. One, back in almost 1700, early 1700, two scientists were doing an experiment in the Oceanographic Museum out in Monaco. And they ground up tentacles of jellyfish, injected them into dogs, and they thought that the dogs were going to be protected, just like giving them a vaccine. Mm-hmm. Yet when they re-injected the dogs, they dropped the blood pressure, the bronchi constricted, and they died.
Wow.
So they called that phenomenon anaphylaxis. Now, they do not associate to the mast cells then. But a few years before, Dr. Paul Ehrlich in Germany was staining cells, and he used a dye that was blue, but he identified that certain cells in the tissues of animals and humans turned violet. And he looked under the microscope, and he looked those violet little sacs inside these cells. He did not know what they were, but he thought that those cells were feeding surrounding cells. And because the Greek word for breast is mastos, he called them mast cells, or mastocyte, actually. Well, we still didn't know what the cells were doing until about 1947, when histamine was discovered inside the cells. And ever since that time, they've been associated with allergies. And many years later, in the 70s, the Ishizakas identified a particular surface area on the mast cell, which is called a receptor for immunoglobulin E, or IgE. However, the mast cell is like a soccer ball filled with about 500 ping pong balls, each ping pong ball having about 50 or so marbles inside. And when the mast cell is activated in anaphylaxis or in allergy, it literally explodes like a hand grenade, and within seconds, about 50 or so molecules are released from the cell.
That is such a great analogy and really helps understand the concept.
And then over a period of 6 to 12 hours, we call it the late phase, another 50 or so molecules are produced and released, but these molecules are newly synthesized. They were not stored inside those little sacs. So the mast cell has about 1,000 of those little sacs. We call them secretory granules. And we were among the first, I dare say, to report as back as 1978 or so, that the mast cell can release molecules both from within granules and newly synthesized, but without undergoing an allergic or anaphylactic reaction, but in response to many triggers, some pathogenic, some environmental, as well as hormones released under stress. So, in summarizing so far, I think we and colleagues have been missing the forest for the trees by looking at the mast cell involvement in allergy and missing the mast cell involvement in neuroinflammatory processes, especially those that worsen by stress.
Oh, definitely. I wonder if you could elaborate a little bit more about the triggers, some of those triggers you mentioned that do activate the mast cells.
Right. In all honesty, it's hard to separate the triggers because many of them may occur at the same time, as you might imagine. But for instance, other colleagues have reported that Borrelia, which is of course associated with Lyme disease, can stimulate release only of inflammatory cytokines from mast cells without any histamine or the telltale enzyme of mast cells called tryptase. Other colleagues have shown that mold and mycotoxins released from mold also can stimulate the mast cells to release only cytokines. We reported numerous times over the last at least 3 years in the proceedings of the National Academy of Sciences that if we prime the mast cells by adding a cytokine called interleukin 33, other colleagues call this an alarmin because it is released from damaged cells and sort of gets the surrounding other cells going to protect the organism. So if we prime the mast cells with interleukin 33, and then we come in with neuropeptides released under stress, such as corticotropin releasing hormone, substance P, or neurotensin, we can trigger the mast cell to release thousands of units of interleukin 6 or interleukin 1 beta or tumor necrosis factor, and all these three are the most well-known pro-inflammatory cytokines known. So even though the mast cell in its quiescent state doesn't release very many cytokines, and if it's stimulated by allergic or anaphylactic triggers, may release some of these over a period of 24 hours, not right away. If it is primed, as I said, it can release more of these cytokines than any other immune cell known. And we've been missing that all along.
And is that what they are referencing when they talk about a cytokine storm?
That is correct. Now, other immune cells, such as macrophages, can of course release cytokines, but especially in the lungs, the mast cells are very abundant. That's where we get asthma, which is entirely dependent on mast cell activation. And the cytokine storm would be release of huge amounts of cytokines. And in the brain, to which we might return, things are a little different because the brain does not have macrophages, does not have circulating immune cells. The defense of the brain are the microglia. And microglia, you can think of them as spiders with spider webs upon which all neurons kind of crawl and make connections, and that's how we communicate. And the microglia do a very useful function if they're not activated. The useful function is they go around and they prune these neuronal connections or synapses the same way we would prune a tree to make it grow. So that way they allow synapses that really don't serve any purpose to sort of go by the wayside and allow synapses like learning a new language or technique or whatever to solidify themselves and stay as memory.
What happens when they're activated?
If, however, they're activated, they might be activated by a virus, by toxins that might enter the brain through a disrupted blood-brain barrier, by bacteria or viruses that might enter the brain through the nose, because the nose communicates with the brain directly through the tract of the olfactory nerve. Then they get activated and they become macrophage-like. So they start chewing up basically and releasing inflammatory cytokines. And what is unique, taking us back to the mast cell, is that the critical area of the brain that regulates homeostasis, which is the hypothalamus and the thalamus, and the area of the brain that regulates emotions, which is very close to the hypothalamus, the amygdala, have more mast cells than we have in our skin. But obviously, they are not getting involved in allergic reactions because the immunoglobulin E cannot cross the blood-brain barrier to trigger those cells.
Are there other substances that stimulate the mast cells?
There are other molecules that we might not be suspecting. For instance, there have been a number of reports that atrazine and glyphosate, which are herbicides, stimulate the mast cells. There are other reports, including one from us, that heavy metals like mercury and aluminum stimulate the mast cells. And in those cases, or in all of these cases that I've mentioned, no one is allergic to anything. So what do we call these individuals or these processes? Sometimes we call them atopic reactions, meaning someone has the propensity for an allergy, but it's not a true allergy in the sense that immunoglobulin E is involved. Most recently, well, it's been 5 years or now, colleagues like Dr. Akin and Metcalf and Valent described what they call mast cell activation syndrome, where the mast cells are activated, but not necessarily by allergic triggers. And this is uniquely seen in patients who may either have mastocytosis, meaning many more mast cells in their skin or their bone marrow, or individuals who just respond to everything under the sun and they're not allergic. Sometimes this is confused with multiple chemical sensitivity disorder, where individuals there also respond to many triggers, especially chemicals. But I think some of these, or chronic inflammatory response syndrome, some of these I think would coalesce eventually under mast cell activation syndrome.
I remember hearing a presentation at iLads last year, and someone was describing the mast cells being activated around the brainstem, and it just sounded exactly like my own experience with neuroborreliosis.
Well, that's exactly it. First of all, we used to think that it is only the blood-brain barrier that allows various molecules or triggers to enter the brain. As it turns out, this is not entirely correct. First of all, in the lower part of the spinal cord, the blood-brain barrier almost disappears. So molecules might pass into the brain through there. Colleagues at Johns Hopkins some years back identified now a set of lymphatics that also get into the brain. We used to think that the lymphatic system doesn't touch the brain, and as it turns out, that's not true. So molecules from lymphatics could go in. But from my point of view, I wrote a small review in 1990 where I called the mast cells the immune gate to the brain. Because if you take a cross-section of a blood vessel in the brain, you see, of course, two cells that make up the wall of the blood vessel. Those are the endothelial cells. Then around them, you have two other cells. They're called pericytes, and they protect basically the endothelial cells. And that's literally what is the blood-brain barrier. But around them, we've published numerous times, you have one or two mast cells hugging basically the pericytes. And they're loaded with these mast cell granules. So if the mast cells in those locations are triggered to release molecules, they will immediately make the blood-brain barrier leaky. They will disrupt it. So histamine, to give you just one example, and the enzyme tryptase are very vasodilatory. So is vasoactive intestinal peptide and vascular endothelial growth factor, also released from mast cells. So the mast cells in that area not only would allow toxins and other molecules to enter the brain because of a disrupted blood-brain barrier, but they will release their own now cytokines that are pro-inflammatory in that area, and they will also release chemokines that will attract circulating white blood cells into that area. And since the blood-brain barrier is disrupted, the white blood cells will go in now. So imagine the microglia all of a sudden seeing molecules coming from the mast cells, toxins coming from the blood that should have been delivered to the feces or urine, and immune cells. They literally go wild.
Do the mast cells multiply?
So what you have is something like the clones in Star Wars. They start multiplying like crazy, they accumulate in that area, and they cause what we consider a focal inflammation in the brain. And we know it's focal because if it was generalized, you will have either meningitis or encephalitis, and that's not what we have. If it was also attacking all the protective sheaths of the nerves, which is the myelin, then you would have multiple sclerosis, and we don't. So obviously, there's a unique way to somehow affect that area of the body, as I said, that regulates emotions and homeostasis, which is the hypothalamus, amygdala, thalamus area.
Yeah, those glial cells really play an important role in detoxing the brain, don't they?
They do. They do. But as anything else, they can go overboard. And unfortunately, what really worries me with both scientific publications as well as the lay sort of call them publications or announcements over the years is they talk about supporting the immune system or increasing the immune system or whatever. Well, obviously, we don't want to overdo it. So if someone has, let's say, an autoimmune disease, you don't want to increase the immune system even more. The same thing, if we need a few cytokines to protect our body, let's say against COVID or Borrelia or something else, we cannot allow it to go overboard because then it becomes toxic to the body. It becomes an auto-inflammatory problem. So whenever we talk about the supplements or drugs that presumably increase the immune system, we really don't know what we're talking about. And we shouldn't be talking about those. And there's so many supplements sold out there that presumably boost your immune system. And I'm not quite sure I want to boost my immune system in certain cases.
Yeah. And you also spoke about the heavy metals. And I know I've heard some people speak about, using chelation in part of their treatment to get those heavy metals out of their bodies.
Well, first of all, that's a good approach. But again, one should go crazy. If someone has never been in an area where he or she might have been exposed to heavy metals, that would not be, the first thing in my mind. Although I always ask. To give you an example, I had a lady in her mid-50s that I was asked to see in Greece, and she had a lot of both bone and neuropsychiatric sort of problems, and she was on about 4 different drugs for presumably being serum negative rheumatoid arthritis, meaning rheumatoid arthritis, but nothing shows up in the serum, no anti-nuclear antibodies, nothing. So many times we use that term. Well, I suspected that it might be toxicity, and we measured mercury, and it was off the roof. I had never seen such high mercury. And then when I tried to find out why, she was eating practically every day sushi. And I don't mean to point my finger to sushi, but when you use fish and raw fish, etc., those are known. Especially tuna. We have a directive in the United States for pregnant ladies not to eat tuna more than twice a week, etc.
Yes, heavy metals are certainly a consideration. I know that they were a factor for me.
So if I suspect, clearly, we should measure it. And then what we should keep in mind is that heavy metals stay in the blood only for a few months. Then they stay in the urine, or we might pick them up in the urine, for up to 6 months. From then on, it is only in hair because they accumulate there. So not seeing it in the blood or the urine doesn't mean that it's not there. And therefore, if you really want to chase metals down, you have to provoke, quote unquote, the release of metals. So sometimes what one would do is to give actually some binders so that the binders might draw some of the metals out, and then you measure them again. And if they're high, then you continue with chelation therapy. And they're mild chelation therapy, and there's serious chelation therapy that is intravenous. So again, it depends how heavy the metals are, how strong the symptoms are that might indicate chelation therapy. But I wouldn't jump into giving IV DTA or something like this without really knowing how seriously high the levels are, because these kind of chelation therapies have their own very serious side effects as well.
Yeah, and so just to switch gears a little bit, I'm curious to know if you have noticed similarities between people with Lyme neuroinflammatory aspects and people who are not recovering from the COVID infection, the people who are continuing to report that they have, brain fog and fatigue, et cetera.
Right, very, very much so, and I appreciate your question. In fact, I've been seriously looking into this and will be proposing some studies about it as well. Well, we know that many of the neuroinflammatory related symptoms are sort of generalized neuropsychiatric problems. It might be disruption of sleep, it might be anxiety, it might be cyclothemic problems, there might be peripheral neuropathies, sometimes we call them paresthesias, and of course, quite typically, as you said, brain fog, which is reduced ability to recall, to come up with the right words, to multitask, etc. And I was very cognizant of this for, let's say, post-Lyme, however we want to call it, patients. But we were seeing more and more of similar symptoms in individuals who either had very few or mild symptoms after being positive for COVID-19, or who survived even serious illness, but they continued to then have problems, within a few weeks, etc. So much so that the Center for Disease Control about a month ago, just less than a month ago, announced the now recognition of a condition called multisystem inflammatory syndrome. Mind you, this was actually recognized in a few papers, including one in the New England Journal of Medicine, was published back in June, about multisystem inflammatory syndrome in children. And we always thought that children either don't get sick with COVID-19 or they don't have various serious symptoms, meaning they don't end up being intubated. So now the CDC is calling it multisystem inflammatory syndrome -A for adults, while it was -C for children. And just 2 weeks ago or so, I actually published an editorial that this multisystem inflammatory syndrome is very similar to mast cell activation syndrome, which of course is very similar to post-Lyme syndrome. So at the end of the day, what appears to be is either the mast cells are activated, releasing molecules as we discussed, and then affect the microglia, that then they affect the neurons, or in this instance, the virus gets into the brain through the nasal canal, and of course we know that because it can be we can breathe it. Now I don't know whether Borrelia can enter actually the brain in via that route. I wouldn't be surprised, but I'm not sure. But if Borrelia were to activate the mast cells to release the cytokines, as we discussed, clearly the cytokines will do the job. So how do we actually handle such individuals?
It sounds like there's some important research questions to investigate here.
But I just want to basically ask the question, can we prevent, to some extent, the pathogens sort of going overboard and creating a serious problem in our system? In other words, could we give something ahead of time, let's say to those who might be in an area that is endemic for Lyme, or to those who might be exposed to COVID-19 beforehand? And the second question would be, can we do something right after? And the third question would be, if someone has this set of symptoms, which the NIH now calls long haulers. There was a 2-day conference online, of course, last Thursday and Friday from NIH, especially for multisystem inflammatory syndrome and long haulers. So it may well be that the symptoms of long haulers might be either reduced or even eliminated after they've appeared, at least because we know that in mast cell activation patients, in many patients, we can manage to do that. So I'm hopeful in some way. But what worries me is that most of the emphasis throughout this pandemic with NIH has been repurposing old drugs and not necessarily paying attention to natural molecules that might not qualify for drugs, but my God, can reduce the symptoms to a very large extent.
2 questions. Where can our listeners go to get more information? And also, I understand that you've formulated some neuroprotective natural molecules.
Yes. So let me first say mastcellmaster.com. And there will be live videos as well as many PDF of the publications, so the readers or your listeners do not have to go looking for them. But if you allow me a minute, I would like to say that much of what we've done over the last few years now has been picked up within the COVID-19 arena as well. For instance, I helped formulate a couple of natural molecules. I'm sure you know them, quercetin and luteolin, because they're antioxidant, anti-inflammatory, and neuroprotective. But we formulate them in olive seed oil to increase absorption, because in a powder form, they're absorbed less than 10% in the gut. So those have been around. One is called Neuroprotect, that has both. One is called Pure Lute, that has only luteolin. And one is called Fibroprotect, that has both luteolin and quercetin and some coenzyme Q10, as well as L-carnitine for those that are fatigued, as many patients are. What is fascinating, and I wrote a review about a month ago on this, that 3 laboratories independent of ours, by using computer simulation, showed that quercetin and luteolin are the best potential blockers of the CoV-2, which is the coronavirus that induces or causes COVID-19, binding to target cells. And then we showed in the laboratory that the spike protein, that is the corona protein that binds to a receptor on the surface of the cells, allowing it to enter the cells, is present actually in mast cells, and we can block it. So basically, luteolin, more than quercetin, but the combination probably even better, can inhibit the binding of COVID-19, can inhibit then the stimulation of the mast cells and release of the cytokines. Why would it be using such molecules? We wrote it twice, and now 3 other studies have shown that what we said was true. And 2 hospitals, one in the United States and one in Canada, are proposing now on their website the use of COVID-19 potential protection by using quercetin and luteolin. And I would just ask by the government to review actually a grant application using luteolin for prevention of at least COVID-19 related symptoms. And I feel very strongly that in the absence of anything we have for treating COVID-19, leaving aside the vaccines, which is a whole different story, it would be almost unethical not to be using molecules that are otherwise safe, and they seem to be basically getting 4 birds with 1 stone. The one thing that I would caution is that whoever uses such supplements, they should look for the purity, the source, and the amount, and whether they're made in good manufacturing practices. Because as you know, when the word goes out, all kind of formulations will show up, and they will be very tricky because they might say we contain luteolin, but you wouldn't know how much you have to take and how pure it is, and whether the impurities can actually cause a problem. That's why just last week, we published a paper that is called Luteolin Supplements, Not All Glitters is Gold. And I review all the luteolin and quercetin containing supplements available in the United States. And you will see the amounts are very different, the sources are very different, the purity is never actually mentioned, and the wording is very confusing. So they might say luteolin complex or quercetin complex. and complex might sound exciting, but at the end of the day, they have very little of it. And that's because these molecules have color, they're yellow. But the cheapest source to make a similar color is rutin, which is related to quercetin luteolin, but is very cheap, but it's not as active as any one of those 12 molecules. So I think reading that review, that short review, would be an eye opener, both in terms of how complicated the formulations are and how misleading they also are.
Thank you so much for educating us today, Dr. Theoharides. I'm so inspired by your research, and I really hope that we can get you back on our podcast in the future so that we can stay current on all of the research that you're involved in. Wow, that was fascinating. That was Dr. Theoharides, professor of immunology at Tufts University. It was so interesting to hear that some of the COVID long hauler patients are also experiencing mast cell activation. Thank you for joining us as always, and in the meantime, stay safe in the outdoors.